blah. There we go. No warm-up today, everyone at home. We're just going to jump right into our lesson. Don't worry, it's not this. That was last year. All right. Underneath, well, I guess there's not underneath anything. Got a pencil for a title? Got a pencil? Okay, today we're going to talk about something called the Pythagorean Theorem. Pythagorean. Theorem. Theorem.
How much do you have to write that?
Like one more time. Okay, so in order to talk about the Pythagorean theorem, I want to talk to you a little bit about what that means. So back in the day, and I'm talking like thousands of years ago, there was this group of people who followed a dude named Pythagoras, and Pythagoras was obsessed with math, among other things, but we'll talk about that a little bit later. But he was obsessed with math, and one of the things he was obsessed about was right triangles. So let's all draw a right triangle. A right triangle is a triangle that has a right angle. Okay? Now, like all triangles, a right triangle has how many sides? Everyone, it's got 3 sides. No surprises here. It's got 3 sides, but I'll tell you this. The interesting thing about a right triangle is that it has 3 sides, but it actually only has 2 kinds of sides. It has 3 sides. It has 2 different kinds of sides. So when I say teach, I want you to say, okay, which 2 sides do you think go together and have the same name? And which side do you think is apart from those other 2? When I say teach, I want you to say, okay, which 2 sides do you think go together on this right triangle? And which one side do you think is apart from those 2? Has a different name. Give it a try and teach. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Does someone by raise of hand think they know which 2 sides go together? What do you think, Almas? Yeah, the ones that make a right angle. Those have the same name. The 2 sides that come together to make that right angle are both called... I'm dropping my pen. Got a pencil? They're both called legs. This side is a leg, and this side is a leg. Now, if those 2 are the legs, you can probably guess what the other side's called. The 2 that make a right angle are called the legs. Did anybody have some guesses about what that other one might be called? What do you think? Torso? Not torso, Akora? Not an arm, Almas? Knee? No, you're kind of dancing around it. Yeah. Not the body. Come on. What's that? Not a hip. Not a hip. Come on. You guys are like right there. You guys are right there. Cora. Foot? Nope. Not the foot. Not the foot. Not the stomach. Oh, you guys are so close, though. Yeah. Elbow, not the elbow. I'll just tell you what it is. Can I first tell you what my favorite wrong answer is? My favorite wrong answer is ground. Because if those are 2 legs, it's like they're standing on the ground. So I like that. Guys, you're going to feel so silly when I tell you what it is. You're like, oh, duh, of course it is. Guys, it's the hypotenuse. I know, you guys were right there. It was on the tip of your tongue, right? You were like, oh, I almost had it. I'm just kidding. I just like to do that every year. Okay. So the 2 sides that make a right angle are the legs. The other side, the side that does not make the right angle, is the hypotenuse. Put your pencils down for a second. I'm just going to draw a bunch of right triangles, but you don't have to draw them. Nope, don't draw them. Because I'm just going to point to their parts, and I want you to tell me if they are a leg or a hypotenuse. So that part is a... That one? Oh, Hey, this one? That one? That one? That one? That one? Cancel. That one? That one? That one? That one? That one? That one? That one. Yes, indeed. Okay, very good. All right. Okay. All right. I love this lesson, you guys. I get to have some fun with it. Okay, so why do we care about this? It turns out, guys, that there's a very peculiar property about right triangles and only right triangles, and we call it the Pythagorean theorem. So, got a pencil? The Pythagorean theorem states that the areas of the squares on the legs of any right triangle always, and I mean always, add up to the area of the square on its hypotenuse. Whew. You just write that down. I know you're probably like, what? But that's okay. That's okay. We're going to look at an example, and you're going to catch on pretty quick of what I'm looking for here. Kind of a long, annoying sentence, but that sentence means all the difference. Like, if you can get to a place where you really understand that sentence, you're going to get a 4 on our skill check. You're going to get a 4 on our skill check on this. Like, really, this sentence is everything about what we're up to. It does not get very much more complicated. And once you get that, guys, we're going to draw a right triangle like this. Uh-huh. Let's draw a little triangle right there. And we're going to say that this leg measures 4 inches, and this leg measures 3 inches. And we don't know how many inches the hypotenuse is. Here's what the Pythagorean theorem is trying to tell us. I want you to draw 2 squares. One of them is going to be attached to that leg, and one of them is going to be attached to this leg. Draw a couple of squares that pop right off of there. This leg was 4 inches, so the area of the square would be 4 times 4. What's 4 times 4? Just say it. 4 times 4 is? Ooh. Yeah, it's 16. Will you guys punch that in your calculator just to make sure you're feeling good on there? What I'm saying, guys, is that the area of this square is 4 times 4, because it has to be a square, so they're both the same. And 4 times 4 is what? Everybody, 4 times 4 is? It's 16, so that's 16 inches squared. This square is 3 by 3. What's 3 times 3? Everybody, 3 times 3 is what? Everyone, 3 times 3 is? 9. So the area of this square is 9 inches squared. This is the important part. Read the Pythagorean theorem again. The Pythagorean theorem states that the area of the squares on the legs of any right triangle always add up to the area of the square on its hypotenuse. I know the area of the squares on the leg of this right triangle. How could I use the Pythagorean theorem to find out the area of the square on its hypotenuse? Take a moment to read that sentence and think about how I could use 16 and 9 to come up with the area of the square on the hypotenuse. Give it a try, and here we go. Teach! Hi, Cora. What's that? It is. Mm-hmm. Make sure you talk to your partners about how you got that, because that's important. Yeah. What does the Pythagorean theorem say? Okay, so what do you think? That's right. Very good. Hi, Almas. It is very good. Mm-hmm. Very good, Almas. Okay. Oliver, yes, sir. It is. Mm-hmm. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1 in a Texas accent? Let's see here if I can get a little bit of help. Ain't nobody sitting there. Or there we go. Oh, here we go. Okay. So, Malia, this said that the area of the squares on the legs of any right triangle always add up to the area of the square on its hypotenuse. What do you think I'm going to do with 16 and 9? We're going to add them together because the area of those squares has got to add up to the area on the hypotenuse. So we could do 9 plus 16, and that is 25. That means the area of this square is 25 inches squared. But I wanted to know this distance here. So what question can I ask myself to find out what that distance is? You think you know, Dash? What multiplied by itself is 25? And do you guys know what number multiplied by itself is 25? What is it, Molly? It's 5. And if you weren't sure, you could just use the square root. Whoops, that's a divide by. The square root of 25 is 5. So that distance was 5 inches this whole time. After seeing that once, how many of us are feeling just fine and dandy about that? You guys doing all right? I love that. Love to see it. You guys are doing a great job today, and I think y'all do deserve a point. Can I get a big Texas yeehaw? It was kind of like a lower mid-sized Texas yeehaw, but I'll take it. I'll take it. Okay. Got a pencil? Oh, it's all right. All right, here we go. Let's see here. There we go. We're going to draw another right triangle. Okay. Another right triangle. Let's go ahead and say that this is 6 yards and that this is 12 yards. How can I use that information to find the area of the square on its hypotenuse and then use that information to find the side length? Go ahead, guys. You might get a nasty number, round it to the nearest thousandth if necessary, but see what y'all can do. How can I use the Pythagorean theorem to build some squares and be able to make this happen? How are we going to find the length of that there hypotenuse? Give it a shot now and teach. Go ahead, Jack. Get this guy written down here. I want to see this here right triangle there. See what y'all can do. Perfect. Tell me what y'all are up to here at table C. Ooh, actually, Jayla. So I need to know the area of the squares on those legs. So instead of multiplying 12 times 6, that'll help you find the volume, or sorry, excuse me, the area of the triangle. I'm just going to do 12 times 12, because that'll give me this square. And then 6 times 6, that'll give me that square. And then we use the Pythagorean theorem like we did on the last one. I'm going to come on from back to the front, because I went front to back last time. You guys feeling okay with your table F? Awesome. You guys feeling good about that? Table D, you guys feeling okay about this guy? Love to see it. Oliver, you got a question now? Oh, that might be the area, but I don't think that's the side length. How do I use that to find the side length then? Yeah, go ahead. What you got for me? It's not 90. It's not 90. You got the right idea, though. 180 is part of my problem. Shield, what's up? That sure is. That's it. Very good. Let's see here, Molly, and then Almas. That's the beautiful. That's the exact right there. And then if you hit that little button, you'll get the approximate. Bam. Bam, bam. You got it. Heck yeah. Now we're talking. Hey, Dash. Beautiful. That's 100% right. Well done. Well done. All right, y'all. Whew. Can I get you back up here in 5, 4, 3, 2, 1? All right. Akora, what'd you do with these numbers here? Yeah, 12 times 12 gives you the area of this square, which is 144 yards squared. What else did you do? And 6 times 6, that would give you the area of this itty bitty square over here, which would be 36 yards squared. And what'd you do with that number? Exactly, because the Pythagorean theorem states that the area of the blue square and the yellow square is going to add up to this big square right here, which I've elected to make, I don't know, purple. There you go, a little purple square right there. Ain't that what you get when you do yellow and blue? Oh, whoops. And it was right there, too. Whoopsies. Ah, well. Such is life. Okay. There we go. So that would be 180. Is that right? When you add them together? So the area here is 180 yards squared. And how can I use that, Akora, to find the distance of that hypotenuse? You just take the square root of it. Exactly. And your calculator will actually give you the exact, which will be important for our skill check, so make sure you're ready to go with that it's exactly 6 square roots of 5 yards. But again, depending on what you're doing with this, if you just want it as an approximate, about 13.416, which is about 13.416 yards. How many of us were able to get that or see how we got that and ain't too alarmed? Beautiful, not too bad, right? Let's do another one here. Got a pencil? Oh, got a pencil? Okay. What if I told y'all both of those legs was the same? And that one of them was 2.8 centimeters. How could you use that to find the length of that there hypotenuse? If I told you that them there legs were the same length, how could I use that to find that there hypotenuse? Give it a shot and teach! Depends on what you mean by them. Beautiful, very good. Yeah. And since there's two of them, what you going to do with that number there? So when you did, go ahead and do that again. 2.8 times 2.8. Beautiful. Oops. There you go. That's the area on one of them, okay? Now, how many of them is there, though? Oh, how many are exactly the same as that 2.8? Just two. So multiply that number by 2. Oh, just 2, actually. Yeah, just 7.84 times 2. Was it 4.8 or 8.4 now? I can't remember. 8.4, there we go. Crisis averted. Perfect. Now that's the area on this square on the hypotenuse. So what do I do with that number to find out the side length? Take the square root. That's the idea. Is what number times himself is going to give me 15.68. So use the square root. Hit that guy, then that guy. Oops, I blew it. Sorry, Claire. second, and then that guy. There you go. And it was 15 point what? 68. There you go. And then you should have your answer, okay? Beautiful. All right, let's do it. Whew, okay. Can I get you guys back up here in 5, 4, 3, 2, 1. All right. Nora, what you going to do on this? Very good. That gives you the area of the square on this leg. That's 7.84. What'd you do with that number? Beautiful, because there was a perfect copy of it on the other side. And what does this number represent? I'll tell you, that number represents the area of this square right here. Because that is the sum of the area of this square and this square. Does that make sense? And then now that I know that that's 15.68, did you say? What am I going to do with that number to find the side length? The square root, yeah. The square root of 15.68, was it? 3.959, so that would round to, let's see here, that 59 needs to round up to a 60, so 3.96. That's about 3.96 centimeters. How many of us were able to get that or see how we got that and aren't too concerned? You guys doing all right out there? Beautiful. And that'll be 5 minutes for the Texan. How are you guys feeling on this so far? If I give you the legs of a right triangle, give me a thumbs up if you're like, yeah, I'll get the hypotenuse, no trouble, whatever. Big thumbs down, not sure what I would do with that, and then dial it somewhere in between. It looks like we're feeling pretty confident on it. A couple of little shaky ones, but we'll see what we can do. I'm going to change the game on you just a little bit, and I want to see how you handle it. Got a pencil? What if I told you that this was 5 miles, this was 7 miles, and this was an unknown number of miles? I told you I just changed the game on you, but some of us might not be sure in what way. When I say teach, I want you to say, okay, how did I just change the game on you, and what do you think we're going to do about that? Talk to each other and teach. This is like a level 2. Oh. Molly. Let's see. How'd you get that number? Oh, it's true, but remember, I actually have to have the squares. It's not that the sides add up to this side. It's the squares. Oh, but remember, that's a square on there too, right? So what would the 7 times 7 be? Uh-huh. See, there we go. Now we're talking. Mm-hmm. Oh, we got some realizations going on. Love to hear it. That's okay. So what do we know about it?
We know these two.
And we know that this square plus this square will be equal to that square, right?
Yeah. Should we divide these two?
Well, let's see. What would the area of this square be?
The square.
Yeah, I'm cool with that.
So what would just do kind of like five, oh, no, 5 times 5.
Yeah, it is.
It is?
Because it's a square, right?
Yeah.
5 times 5. Mm-hmm.
Okay.
Yeah, use your calculator. That's okay. No shame in that.
6.5.
There you go. And then what's the other square that we know? It looks right. It looks right. Yeah, because then did you do this minus this? And then take the square root of that? Beautiful. Then you did it. And you nailed it. However, the area is 24? Around there, yeah. Because the side length, wait a minute. No, the side length will be a lot less than that. Because if we don't take the 24 and divide it by 2, we need to take the square root of it. Yeah. You're on the right track. Ah! It should be something around there, yes. Perfect. Ooh, well, hold on. Because the thing is, Gavin, I know that these two squares are going to add up to this one, right? So I need to know 25 plus what is going to give me my 49? That's the question. Let me see. Aha, so 24 would be the area, and then you take the square root, and you get something around that. Absolutely. Very good. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Molly, what's going to be your first step here? Yeah, 5 times 5 will give me the area of this square, which is 25 miles squared. And then 7 times 7 will give me the area of this square, which is 49 miles squared. And then how am I going to use that to find the area of this square? And why minus instead of add? That's right. I know that 25 plus something is 49, but I don't know what that is. And the way to do that is to say, well, what's 49 minus 25? Because that will give you whatever's left over. And what was 49 minus 25? So that was 24 miles squared. What am I going to do with that number to find the missing side length? Yeah, we're going to take the square root of 24. Oops. We're going to hit the right buttons as well. The square root of 24. Now that number is important. 2 square roots of 6. That is the exact length. I know that number looks crazy, but that means that this is exactly, what was it, 2 square roots of 6? 2 square roots of 6 miles. But again, if we're trying to build a fence there, we don't care about that. We want it approximated to the nearest thousandth. 4.8989. If I cut it here, what comes after the 8, everybody? A 9. So should that 8 stay an 8, or should it turn into a 9? 4.899. It's about 4.899 miles. Whew. How's that coming? Thumbs up, easy peasy, lemon squeezy, big thumbs down, hating every second of this, and then dial it somewhere in between. Where is everybody? Okay, let me give you one to work on with your partners, and I'm going to come around and check in on everybody, okay? Here we go. Got a pencil?
Absolutely.
Oh, we can do better than that. Got a pencil?
Absolutely.
Okay, here we go. What if I told you that this was 10 inches? This was an unknown number of inches, and that this was 17 inches. See what you guys can come up with. I'll come around. In fact, I'm going to let you guys work on this for like a minute, and then I'm going to come around and check in on everybody, okay? And make sure everybody's feeling comfortable with this guy before we move on to the next idea. Give it a shot and teach. Take another 20 seconds, and I'm going to come around and check in on everybody. And if I can get the exact and approximate, I would love that. Like the weird root thing that your calculator says, and the approximate with all the decimals. By all the decimals, I mean rounded to the nearest thousandth. Right. Some handitizer. Be right with you. I'm going to come one table at a time. I'm going to check in with everybody. All right. What'd you guys wind up getting? Let's see here. How'd you get that? Is that what you got as well?
I got 3.7.
Those. How did you get that? How did you get that answer right there? Uh-huh.
Times this by 2.
Oh, you got to multiply that by itself. Yeah, there you go. Multiply that by itself. And then how did you get this result?
Oh, I did the same thing.
Oh, there we go. Okay, that'll happen. No worries. How'd you do over here, Luke?
I'm still trying to figure it out.
That's okay. So here's the thing. I know that the areas on these two legs are going to add up to the area on this hypotenuse.
Yeah.
So it is. Now turn that into get that approximate on there too.
Wait, which one do I times by itself? Is it the leg?
Actually, both of them. So you do the 10 times 10 and the 17 times 17. So we need to find the area of these squares.
Yeah.
What's 17 times 17? Yeah, punch it in there. I know, I was like, oh, it never went up to that.
289.
Awesome. What's 10 times 10?
100.
Perfect. These two have to add up. The two squares have to add up to this. So what can I do with 289 and 100 to find out this?
Can you subtract that?
That's exactly what we would do. There it is. Oops, other way. We got to do the big one minus the small one. Beautiful. So that's the area on this square. Now, what can I do with that number to find the side length?
Times it by itself, right?
Or what, we have to ask what number times itself would give me that. And for a calculator, that's the what?
I don't get it.
That's okay. That's okay. So we need to, and I love that you saw that answer and you're like, that can't be right. Because it isn't, right? I'm asking what number squared, is that a 2? Did I just do an upside down 2 correctly? 189. Don't blow it. Is that a 9 or is that a P?
No, that's 9.
Yes, I did it. So what number squared is 189? And to find that out, we have to take the square root of both sides. So what is the square root of 189? That's saying what number times itself gives me 189?
320.
3 root 21, that's your exact. And then hit the little arrow buttons and you'll get the approximate.
13.74.
That's it. That's all there is to it. Does that make sense?
Yeah.
Perfect. Very good. You're very welcome. Kevin, how'd you do over here?
So, I got...
Yeah, you nailed it. Doing good here, Dash. Yep, nailed it. Very good. What'd you get over here, Cora? Very good. Perfect. The square root of 189, which is the exact would be reduced to 3 root 21. How'd you do, Reese? Does that make sense how we got that? Feeling good? How about you, Jayla?
I got the same.
And are you feeling good about how we got there?
And
Love.
I did the thingy.
Yeah, great. So that's the exact. And if you want the approximate, hit that button right there. Yeah.
Oh, wait. I messed up.
No, you're okay. Whoops, we don't want the third root. Go ahead and clear it out for me. I got you. I got you. If you wanted to put in 3 root 21, hit 3. Now hit second. And then actually just this one, because we don't want the 3 in the index. There we go. 21. Ooh, we actually, here's the problem. Hit clear. Is that I want that arrow to be out of the root. So you have to hit the little over key. Now we're talking. Bam. There you go. Good. How'd that go, Lucy? Did you get that okay? Okay, I'm glad we're talking. Okay, here we go. So what we're going to do here is we're going to find the area of these squares. So let's start with this one. What's 17 times 17? That would be the area of that square. $289. Let's write that down. What's the area on this square? What's 10 times 10? 100. Beautiful. Let's write that down. So I know that this square plus this square is going to equal that square. What can I do with this number and this number to find out what that one is? That's okay. So here's the thing. So this was 289. I'm just going to fix that really quick. You just saw it wrong. It's okay. I know that this number, whatever it is, plus 100 has to be equal to 289. Is that a 9? Yes, that's a 9. How can I find out what number plus 100 gives me 289? What can I do with these two? That's okay. Let's simplify it a little bit. So we'll forget these numbers for a second. Let's think about it like this. Let's say that we're playing a weird game, and it's like, all right, Lucy, I'm going to go 3, 2, 1, and then we're going to take all the money that's in our pocket and throw it down. We'll go 3, 2, 1, and we're like, bam! And we count up all the money that's in here, and there's $10. And you're like, well, I know 7 of it's mine. And I was like, I didn't count mine before I did it. But if there's $10 in there, and you know 7 of it was yours, how much of it was mine? How did you get that number? What'd you do with 10 and 7? That's what we're going to do here. 289 minus 100. And what do you get? Yeah, 289 minus 100. Awesome. So let's write that number down, 189. Because that's the area up here. Now, in order to find out what that side length is, I have to take the square root of that. So hit second. And then the square root button lives here. There you go. And then 189. And then enter. That's the exact 3 root 21. Hit that button for me. And that's the approximate. That's all there is to it. If I get both the legs, I add the squares and take the square root. If I get a leg and a hypotenuse, I subtract them, and then I take the square root. Does that make a little bit more sense to you? Good. Excellent. How'd that go, Molly? Yep, looks beautiful. And how'd you do over here? Yep, very good. Excellent, Sophie. How'd you guys do over here? Perfect. Yeah, that's exactly right. Very good. Very good, you guys. Very good. Ooh, except that 3 isn't in the index. It's on the side. If you look at your calculator, when it says 3 root 21, the 3 is actually on the side of your root, not in the index. Yeah, because that would be the 3rd root of 21, which would be different. Hi, guys. How'd you do over here, Cora?
Mine. It's kind of messy.
I'm here for it, though. I get it. Yep, perfect. Awesome. And then how'd you do over here, Rachel? You love to see it. Love that. Okay. All right, guys. Can I get you in 5, 4, 3, 2, 1? Okay. Let's see here. Rachel, what was the first thing you did with this? Which was 189 inches squared. Uh-huh. Oh, sorry, 289. I'm getting ahead of myself. 289 inches squared. 100 inches squared. Great. Uh-huh. Yeah, because I know that the leg and the leg have to add up to the hypotenuse. So the hypotenuse minus the leg square is going to give me the other leg. That would mean that this square here is 189 inches squared. But how do I find the side length given that? Yeah. The square root of 189, and you get 3 square roots of 21. That's the exact. That's important. And the approximate is 13.74. After the 7 comes a 7, 8. 13.748. Or 3 square roots of 21. How many of us were either able to get that or see how we got that and aren't too concerned? You guys doing okay? Beautiful. You guys are doing great. Thanks for letting me come through and help you guys out. I think you guys do deserve a point. Okay. I'm going to have you guys do a math problem that got a man killed. This math problem got a man killed. I think so. I talk about this guy an awful lot. If I have a right triangle, and these two side lengths are the same, and those two side lengths are 1 unit, what is the measurement of the hypotenuse? What would the measurement of the hypotenuse be? Know that this problem got a man killed, and give it a try. Teach! And in case you're curious, guys, do you think he was killed because he got it right or because he got it wrong? Nope, not one. A two's got something to do with it. Yeah, he was killed for getting this problem right. But I promise if you get this problem right, you'll be safe. Also, if you get it wrong, you'll be safe. That made it sound very alarming. Like, yeah. Yeah, there it is. Nailed it. Mm-hmm. Let's see here. Yep, you're good. Mm-hmm. Sure is. Okay. Can I get you guys back up here in 5, 4, 3, 2, 1? Reese, how would you handle this? Which is 1. Right, because there's 2 of them. Or, oh, actually, I think we're good, because the 1 times 1 was this one. The 1 times 1 was this one. Add them together, and you get this one. And then what do I do to this number to find out this length here? Yeah, we take the square root of 2, which our calculator very unhelpfully says is the square root of 2, which is about 1.414. How many of us were able to get that? How many of us were able to get that? So I told you this problem got a man killed. This problem got a man named Hippasus killed way back in the day. He was one of the Pythagoreans guys. And basically what happened was this. Pythagoras did not believe in irrational numbers. He thought that every number could be written as a fraction of integers. And one of his students, Hippasus, actually proved that you can't write the square root of 2 as a fraction of integers, that you can't get something you can count to on top and something you can count to on bottom. And when Pythagoras realized that he was right, that there really are irrational numbers and there are numbers you cannot write as a fraction of integers, he told the rest of his followers that that guy was a traitor and to tie him to a chair and throw him in a river, and they did. Yep. That is very true. That is 100% true. That is absolute. He did not go to jail because I forgot to mention, guys, Pythagoras was a crazy cult leader. He loved math, but he also loved being a cult leader. But don't worry, guys, in case you're worried, do you guys think Pythagoras might have made some enemies? Yeah, by killing people over math. So one day Pythagoras is sitting around and he's talking to his followers and being like, yay, math's the best. I love math. How about you guys? And then someone kicks down the door. Bam! Do you remember my brother, the man you killed? And Pythagoras was like, you're going to have to be more specific. Like, he was way more than one. It was not just Hippasus. And they were like, get him. And he's like, bye. And he dives out of a window. And he's running away. And suddenly he stops. The guys catch up to him. And they're like, oh, Pythagoras, why did you suddenly stop? And Pythagoras turns to face his attackers. And he says, I refuse to cross this wicked bean field. Because he was standing in front of a field of beans. And they said, why? And he goes, because in my beliefs, there is nothing closer to the gods than math. And nothing further from the gods than a fart. And we all know that beans are the musical fruit. And that the more you eat, the more you toot. He would not go anywhere near beans because he thought farting was unholy. And the guys chasing were like, that's awesome, because you're like really fast. Stab, stab. And then they stabbed him, and he died in front of a bean field. I kind of hope they rolled him in there, just to be jerks. You know what I mean? But the point is, guys, irrational numbers exist, and that's okay. We're going to talk more about how to deal with these irrational numbers inside of right triangles tomorrow. But for now, guys, just go home, let this cook. We'll come back, and we'll keep talking about Pythagorean theorem. That's all I got for you guys.